All right, so today we're going to be talking about exponential functions. Everything in this section should be review from Algebra 2 exactly the same way as it was in Algebra 2. So hopefully it won't be too challenging. Not quite as easy as yesterday's, which was super short, but shouldn't be too bad. So exponential functions, our parent function for those is f of x equals b to the x, where b is greater than 0 and b cannot be 1. So on these exponentials, we had a parent pattern that I always used in Algebra 2 when I taught it, and the parent pattern is to use -1, 0, and 1 as your left and right movement. And then the values that will be your up and down values will be 1 over b, 1, and b, where b obviously is the base of the exponential. So when we're using this parent function and the rules in the parent pattern, we, for transformations, end up with something that's in this form. And most of this should, like I said, seem the same as what we had in Algebra 2. For some reason, my colors aren't working today. It's only like currently, you can see on my colors, I have selected maraschino cherry, but it's still drawing in black. So sorry about that. Guess we're not going to have any color coding today. So A controls our vertical shrink or vertical stretch, same rules as we've always had for everything else. B is the base. B does not control any type of transformation. So you should never, ever, ever be listing a transformation based on this number, because it will be a number, but it's not a transformation. C controls our horizontal shrink and stretch. H, as always, controls horizontal shift. And K controls our vertical shift. So most of the homework is going to be just graphing some parent graphs. There are a couple where it just asks you to, the first two just ask you to type some exponentials in your calculator and estimate them. So that I don't think we need to do an example of. I would think we'd be pretty competent at that. So here in example 1, we're going to graph the functions in the same coordinate plane, and we're going to graph and give equations of all the asymptotes and list the domain and range. I really wish my color coding was working because it would be really extremely helpful for this example. So I apologize because we're going to have 3 different equations. F of x equals 3 to the x, then g of x equals 3 to the negative x minus 2, and then finally h of x equals negative 3 to the x plus 1 plus 3. So f of x is, hopefully you recognize, just my parent graph, and g of x and h of x are both transformations of that parent graph. Now here it doesn't ask us to list the transformations, so you don't have to list them, but it may be helpful to write them out as part of your work if that helps you. This one, since it's the parent, I'm just going to write out my parent pattern here. So -1, 0, 1. Since b is 3, that means I've got 1 over 3, 1, and 3. And this is always movement from my starting point, which because I do not have any shifts on a parent graph, that means that I'm going to start at 0, 0 and move these amounts accordingly. So I'm going to draw my graph down here, and I apologize, it's not going to be as neat as usual probably because this pen is somewhat difficult to use. Trying my best though. Okay. Sorry that took so long. Just trying to be really careful so my scale doesn't get off. So from 0, 0, I'm going to go left 1 and up a third. Then I'm going to go left to right none and up 1. And then right 1, up 3. Now hopefully you know the shape of an exponential. Goes like this. There we go. On this one are, it says to graph and give equations of all the asymptotes. I have an asymptote on this guy at y equals 0, or you could write x-axis. I'm not going to graph it in because if it's on top of an axis, you usually can't see it anyways. On the other ones that are not on axes, we will definitely draw those in. And then it asks for the domain and range. So the domain, it goes left as far as I want, it goes right as far as I want. So the domain in this case is -infinity to infinity. The range, however, I don't have any negative values, so the asymptote is the boundary. So it starts at 0 but doesn't include 0 and goes up, so goes to infinity. So there's my parent graph. Now, when I look at g of x has a negative up here, which again, we studied all the transformations before. When it's negative up there in the same place as the c, essentially, which would control horizontal shrink and stretch, that also controls reflection over, excuse me, the y-axis. So this one is going to be reflected in the y-axis. And I also have a shift vertical, so vertical shift down 2. Now, whenever I have a reflection in the y-axis, what that does is that changes my x-coordinates. And if you think about it, when I look at my parent pattern, if I'm writing them out as I usually would, it has the same b, so the parent pattern is the same. But anytime we have an a value or a c value, that shrink or stretch, remember that we multiply the coordinates by the factor. So a reflection in the y-axis is really just multiplying the horizontal coordinates by this factor. So I'm going to multiply this by -1, this by -1, and this by -1. And so then what happens when I do that is once I find my start point, now it's changed to this. 0 times anything, of course, is 0. And so that's going to make a big difference to make sure that that you do that part correctly. All right, so for g of x, we are going to start with the shifts because we always do that when we're graphing. So my shift tells me to move down 2. So this is not a point. This, I make like a little plus sign to indicate that that's where I started my graph. That's also where I will draw in my asymptote, is through there. And so from here now, this starting point is where I'm going to use this. So this says go +1, which means right 1, up a third. So right 1, up a third, right none, up 1. So that's this. Left 1, up 3. Left 1, up 3. And so then I connect. And I'm going to label these since for some reason I'm unable to color code today. So that's g of x now, and this one over here was f of x. Now, I still, for g of x, need to list its key features. So its asymptote is at y equals -2. It's always going to be your k value there. The domain, x can still be anything. It goes to the left with an arrow, it goes to the right with an arrow, so -infinity to infinity. My range this time, though, the lowest value boundary is -2, not including, because it's an asymptote, and then it goes to infinity. All right, last one. This one shows me a reflection in the x-axis because of the negative out in front there. This +1 means that I have a horizontal shift, left 1, and this +3 means vertical shift, up 3. So again, I write out my parent pattern because that's helpful for most people. So I've got -1, 0, 1, 1/3, 1, 3. I don't have a shrink or a stretch, but this is in the same place as a vertical shrink or stretch, the reflection is. So that means I take the vertical coordinates and multiply them all by -1. So that means that this is now going to become -1/3, -1, and -3 to go with these same horizontal movements. So we always start with our shifts. So it says shift left 1 and up 3. So from the origin, left 1, up 1, 2, 3. So I'm going to make my little plus sign here. This is where I'm going to start. That's also where I'm going to draw my horizontal asymptote. And then from my plus sign, I go left 1, down a third. So left 1, down a third, left or right none, down 1. So that would be here. And then from my plus sign, I also go right 1, down 3. 1, 2, 3. And so then when I connect those 3, should look something like this. So this is my h of x. So it's still going on forever to the left and to the right with my x's. So my domain is -infinity to infinity. My range this time, there is no lowest value because it has an arrow going down. So lower limit is -infinity. This time my asymptote is an upper limit. It's a ceiling. So the highest value limit is 3, not including 3. And y equals 3 is my asymptote. And so then that gives me my graph. All right. Sorry again that I couldn't color code. I know that that would have been helpful to have these 3 in different colors, but can only do what we can do, I guess. All right, so we just have one more example, which has to do with compound interest. So I'm going to type out some things here. Okay, so here is our example 2, again dealing with compound interest. There are 2 formulas that we need to know for compound interest. The first is for standard compound interest, which is total amount that you end up with equals the principal, which is the amount invested, times 1 plus the rate expressed as a decimal, divided by n, which is the number of times compounded per year, all raised to the n times t, where t is the number of years. This is the traditional compound interest formula. The other formula that we have is total amount equals amount of principal times e to the RT. I call this the PERT formula. This guy is only for continuously compounded interest. So if it does not say continuously compounded, do not use the PERT formula. You do not have to memorize these formulas. I will write them on the board for you for any quizzes or tests or whatnot. Okay, so first thing we need to do is figure out how much is in the account described after 10 years if it's compounded quarterly. So we're investing $3,000. The rate is 7.25%. So when I go to fill things in, how much is in the account is what I'm trying to find. So that's my A. P, principal, is the amount put in, so that's 3,000. Then 1 plus R is the interest rate expressed as a decimal, so move this 2 places to the left, 0.0725, divided by N, which is the number of times compounded in a year. So quarterly means 4 times a year, so N is 4. And then that should be raised to the N times T. So N, we already said, is 4, and T, the number of years, is 10. So next, I'm just going to use my calculator to simplify this. And you can do this all at once if you want, but I would suggest doing it in pieces. I'll show you exactly how I would do it. Where's my calculator? There it is. And we obviously don't need that anymore. Okay. So if I'm in my calculator, obviously we want to start with order of operations. So on the inside of the parentheses, the first thing I see is that I have division. So I do the 0.0725 divided by 4 first. And then I'm going to add the 1 to it because that's what's inside the parentheses. Usually I stop and write that part down. Now what I'm writing, of course, is an approximation, and I'm not going to use the approximation, but I am going to at least record it. So 3,000, and then that's 1.018-ish. And then I know that 4 times 10 is 40. So I would write this down as an intermediate kind of step. So I've got this 1.018. That was the parentheses. Next thing in order of operations is the exponent. So I'm going to raise that to the exponent of 40. Press enter. And then the last thing now is the multiplication by the 3,000. So just times 3,000. And you can see here how I've never used a rounded value. That's really important because if you use rounded values, your answer is going to be off. And when we're talking about money, it needs to be rounded to the nearest cent. You won't get the same answer to the nearest cent if you use just 1.02 instead of that whole decimal. So please use the whole decimal. So here our answer that our calculator gives us is $6,154.11. So then our last question asks, after 10 years, which would have more money? The account from Part A, okay, so we already know how much it has, or one with a 7% interest rate compounded continuously. So we have to figure out how much that second account would have. Since it says the keywords compounded continuously, that means we're going to use this PERT formula here. So A equals PERT, so P is still 3,000, E is the number E. The rate now has changed because this says 7%, so 0.07, and then it's still 10 years, so this is what we have here. Now, this is pretty easy to just all type in at once. There's not a lot of stuff going on, so I'm going to do that in the calculator. So I'm going to do 3,000, and then there is an e to the x button right above the ln key, so I usually use that. So second e to the x, and then it automatically will give me an exponent. And in my exponent, I have 0.07 times 10, which is going to move the decimal place one place, so 0.7. And then press enter. And I get $6,041.26. So $6,041.26. Now, this is not the answer because the question asked which would have more money. So our final answer is the account from Part A would have more money. All right, continuing on. So that should give you what you need to do the 3.1 homework, which is on page 448.